It is the most anticipated stellar death of our time when the giant star Betelgeuse transforms into an explosive supernova. It will shine in the sky as brightly as the full moon and can even be seen in daylight. Unfortunately, however, we do not know when exactly this brutal demise will take place. After the stellar colossus was almost pronounced dead following some mysterious fluctuations in brightness, it seemed to recover, until now. Betelgeuse is once again attracting attention with mysterious displays of light, and a new study concludes that the shoulder star of Orion could explode much earlier than expected. In 2019 and 2020, the excitement surrounding Betelgeuse was boundless. The giant star made headlines with a drastic loss of brightness, which many experts interpreted as a harbinger of the approaching supernova. There is no question that the explosion of this gigantic celestial body will be an overwhelming spectacle. After all, the red supergiant, which is only 650 light-years away, is 800 times the diameter of the Sun and already shines 10,000 times brighter than our source of warmth and life in visible light. As a result, Betelgeuse is one of the brightest stars in the night sky, which is why the development that began in October 2019 seemed all the more confusing. The star's luminosity, normally estimated to be between 0.3 and 0.4 magnitudes, dropped significantly to 1.1289 magnitudes, while its temperature fell by about 100 degrees Celsius. The drop was so significant it could be seen with the naked eye, causing Betelgeuse to slip to 21st place on the nightly star chart. Astronomers associate such phenomena with an imminent supernova due to two reasons. The Orion shoulder star has reached the last stage of its development as a red supergiant, and strong expansion combined with decreased brightness could herald a final explosion. However, the timing remains elusive since no precise observations of supernovae immediately before their explosion exist. Betelgeuse's explosion, when it happens, will make it as bright as the full moon for weeks, outshining other stars. As the brightest and closest supernova in recorded history, it will even be visible in daylight. But recent fluctuations in its brightness suggest that the dust ejected during a massive plasma eruption in 2019 caused the dimming rather than an imminent supernova. Subsequent observations with the Hubble Space Telescope revealed that the eruption created a dust cloud that darkened the star by nearly 2/3. While Betelgeuse regularly ejects stellar material, this event was extraordinary, involving mass loss 30 million times greater than the Sun's. By 2023, Betelgeuse had reversed its brightness dimming and shone significantly brighter than usual, only to experience another notable drop in luminosity. Whether this development relates to an imminent supernova remains unclear. Experts agree the explosion could occur tomorrow or a million years from now. A study from 2023 by researchers from Tohoku University in Japan speculates that Betelgeuse may be much older than previously thought, suggesting it could explode within a few hundred years rather than 100,000 years. However, this study has faced criticism for conflicting with other observations. Interestingly, recent analyses suggest Betelgeuse might have a companion star, whose existence had been overlooked due to its low mass and proximity. The companion star may contribute to brightness variations by influencing dust clouds and being outshone by Betelgeuse. Researchers are now aiming to confirm its existence using large telescopes. The prospect of Betelgeuse harboring a hidden companion star opens up exciting possibilities for future observations. With advancements in telescope technology, such as the James Webb Space Telescope (JWST) and the upcoming Extremely Large Telescope (YLT), astronomers are better equipped than ever to uncover the secrets of this celestial giant. Detailed observations of Betelgeuse and its surroundings could provide critical insights into the nature of the companion star, its mass, composition, and orbital patterns. By tracking its movements and studying its interactions with Betelgeuse, scientists may be able to refine their models of binary star systems and learn more about how massive stars evolve in pairs. Moreover, the data could help explain the complex processes behind Betelgeuse's pulsations, brightness fluctuations, and mass ejections. For example, The influence of the companion star on the formation and dispersal of dust clouds around Betelgeuse could reveal how such systems enrich their local interstellar environment. This is particularly significant because supernovae, when they occur, contribute heavy elements essential for forming planets and life. Another avenue of exploration involves using high-resolution spectroscopy to examine the chemical signatures of the material ejected by Betelgeuse. These findings could shed light on the star's internal processes, such as carbon burning, and provide a clearer timeline of its evolutionary stage. Meanwhile, astronomers are eagerly monitoring Betelgeuse for any signs of impending collapse. Instruments capable of detecting neutrinos and gravitational waves, such as IceCube and LIGO, could provide early warnings of an imminent supernova, offering humanity a front-row seat to one of the universe's most awe-inspiring events. For now, the story of Betelgeuse remains one of speculation, intrigue, and discovery. Whether it explodes tomorrow, centuries from now, or is already transformed into a supernova whose light is yet to reach Earth, one thing is certain. Betelgeuse continues to captivate scientists and stargazers alike. Its mysteries are a reminder of the vast, dynamic universe we inhabit, a universe that always has more surprises in store. The explosion of Betelgeuse as a supernova will not only be a visual spectacle, but also a scientific milestone. Its relative proximity to Earth, at just 650 light-years away, presents a rare opportunity to study a supernova in unprecedented detail. Unlike more distant events, Betelgeuse's supernova would allow astronomers to capture high-resolution data on the mechanics of stellar explosions, the formation of neutron stars or black holes, and the interaction of supernova remnants with surrounding space. One of the most fascinating aspects of such an event would be the effect of a supernova on our night sky. For weeks, Betelgeuse would dominate the heavens, its brilliance rivaling that of the full moon. Daytime observers might also catch glimpses of its glow, a phenomenon not seen since the last recorded supernova visible to the naked eye, SN 1604, or Kepler supernova, over 400 years ago. However, while spectacular, the explosion would not pose any direct threat to Earth. Supernovae can emit high-energy radiation and particles, but Betelgeuse's distance ensures that these emissions would be too weak to impact our planet significantly. Instead, the event would enrich the interstellar medium with heavy elements such as iron, calcium, and nickel, materials that contribute to the formation of future stars, planets, and potentially life itself. From a cultural perspective, Betelgeuse's supernova would likely inspire a new wave of curiosity and awe about the cosmos. Much like Halley's Comet or the Apollo moon landings, the event would capture the public's imagination, fostering greater interest in astronomy and space exploration. Observatories around the world would live-stream the event, and amateur astronomers with telescopes would have a once-in-a-lifetime opportunity to witness the phenomenon firsthand. For researchers, the aftermath of the explosion would be just as exciting as the event itself. As the supernova remnant expands, it will create a nebula, potentially resembling the iconic Crab Nebula, which was formed by a supernova in 1054 AD. By studying the remnants of Betelgeuse, astronomers could learn more about the distribution of elements, the dynamics of shockwaves, and the birth of compact stellar objects like neutron stars or black holes. Finally, the knowledge gained from Betelgeuse's life cycle and demise could have profound implications for our understanding of other massive stars. It would refine models of stellar evolution, help predict the behavior of similar stars in our galaxy, and offer a glimpse into the processes that have shaped the Milky Way over billions of years. In every sense, the story of Betelgeuse reminds us of our cosmic connection. As we continue to explore its mysteries, we also uncover clues about our own origins and the forces that govern the universe. Stay tuned to Digital Discoveries for more updates on Betelgeuse, its fascinating journey, and the ever-unfolding wonders of the cosmos.